Our next quadrilateral that we are looking at are squares. The properties of squares include all the properties of parallelograms, rectangles, and rhombi. So everything that we have been applying so far, all is true for a square, which is, I think, kind of cool. So our squares have, we've known this since elementary school. Squares have equal sides, 4 equal sides. They have 90-degree angles. Okay, opposite sides are congruent. Opposite sides are parallel, making it a parallelogram. Opposite angles are congruent. Consecutive angles are supplementary, which makes sense. 90 plus 90 is 180. Diagonals bisect each other, so these two and these two are the same. For right angles, diagonals are congruent. So something when we square up these to 90 degrees, we make these sides equal, then it squares up, or no, I shouldn't say square it, but it does make our diagonals equal. Diagonals are perpendicular. I'm going to go ahead and just throw out those 90-degree angles real quick. And diagonals bisect opposite angles. Okay, so let's just dive right in here with the information they've given me. They said if ABCD is a square and AD is 11. AD is 11, and they're asking us to find each missing value. So I know you're like, how in the world are we going to find all of this information with this one piece of info here? And you know what? It's going to happen. You can go ahead and label all sides as 11. Okay, so how are we going to get started here if we only know the sides? And it looks like we're going to need to be finding the angles. All right, well, I know 2 sides, but I don't know 2 sides of this small triangle because I'm always looking for right triangles to help me with sides, so I can use Pythagorean theorem. So I might not can use this one, but you know what? There's another right triangle. This guy right here I can use to find my diagonal. So I'm going to use Pythagorean theorem again. So a squared plus b squared equals c squared. Remember, c has to be the hypotenuse. That's the opposite side of the right angle. Other than that, you can call that a, b. A and b doesn't matter, but c does. So I have 11 squared plus, because this is opposite the right angle, is my diagonal. So plus 11 squared equals c squared. So I get 121 plus 121 equals c squared, which is 242 equals c squared. Solving for c, the inverse operation of squaring a number is to take the square root. And those cancel each other out. Whatever you do to one side, you do to the other. And now I'm going to get my calculator here. Take 242, take the square root of that, and I get C is approximately 15.56. Okay, well, C is my diagonal, which is actually DB. So if DB is approximately 15.56, then if I'm going to split that in half, right, because they bisect each other, just so I know what each of these diagonals are, then if I divide that by, divide it by 2, I get 7 7/78. So this is approximately 7.78, approximately 7.78. I label everything that I possibly can. Well, it also says that diagonals are congruent on a square. So, you know what? Let me just tilt my paper a little bit. This is also approximately 7.78, approximately 7.78. So if I add those together, I would get my 15 5600. Okay, whew. Everything is labeled. Is everything labeled here? Well, no, look, I'm missing some angles, aren't I? So I've got my 90 degrees. All my segments are labeled, but I need to label my corners here. So we said that diagonals are bisect opposite angles. Bisect means cut in half, right? So if this is 90 degrees and I divide it by 2, that gives me 45 degrees. So each of these smaller angles are 45 degrees and they are all congruent. Squares are pretty easy when it comes to angles. And they have 90-degree angles as that interior right there. Okay, now I'm going to go ahead and start answering my questions over here because everything is labeled on my diagram. Okay, so we're looking for segment BC. Segment BC is this side right here, which is 11. Segment AC is this diagonal all the way across there, which is 7 7/800 twice. And I know here that it was 15 5600. BD is the other diagonal, so it will be congruent to AC, so 15 5600. EC is just this small segment right here, which is 7 7/800. Measure of angle DAB. So I'm going to go D up to A over to B. So that's including both of these. I always think of it like the mouth of the angle, like what's inside the mouth. And so D up to A over to B, that's both of those, which is 90 degrees. Okay. Measure of angle AEB. So A down to E over to B. It's going to be hard to see now. So A down to B, that's wrong, AEB. A down to E over to B is this corner right here, 90 degrees. I'm going to run out of colors here. Okay. CBD. C up to B, down to D. So you notice it's this corner right there, 45 degrees. All right, one more here. Let me see if I can get a brighter color to help. BAC. So B over to A and then down to C. So it cuts across. B, A, down to C. So it's only one of those smaller angles, 45 degrees.